Hello, and thank you for joining me today. Today we're going to be talking about writing polynomial functions. So to write our simplest polynomial, we want to write given two or more roots. So we talked about roots in our previous video, how we can create factors from those roots. Today we'll be using those roots to create factors to multiply out to create our polynomials. It sounds like a lot. It's just a lot of multiplication. So first thing we want to know is that our roots can be rational. So that would be numbers like 3 or 2/4, that's 1/2, or 1/5 or anything like that. They could be irrational, which is using square roots of things like square root of 7 that doesn't come out nicely, or square root of 2 doesn't come out nicely. Or they could be complex. Remember we did a plus bi back in the day? So we'll be using things with I as well for complex roots. And the one thing you want to remember is that irrational and complex zeros come in pairs. So if you have a square root of something that doesn't break down nicely, or you have a term with an I in it, you need to use both it and its conjugate. So if you don't remember what a conjugate is, here is my example. So if you have 3 plus 4i as a 0, you also have 3 minus 4i as a 0. If you see a positive square root of 3, that also means a negative square root of 3 is a 0. This is not the case for real numbers like 3. That would just have one factor to go with it. So let's try multiplying these out. Now I know for a fact you are going to run out of space in this little spot. I mean, I don't know if you can see this, but these are my notes, and they're gross. So if you need space to write the rest of these, the back page of your notes packet is blank, so you can use that to write the rest of these if you run out of space. I'm going to try and fit them all in the best of my ability, and wish me good luck. So the first thing we want to do, I have my roots are -2, +3, and +4. I start by writing my factors. So I have x plus 2, so you use your opposites, x minus 3, and x minus 4. So I take the opposite of everything that I have. And now I'm going to FOIL or use the box to multiply. I do the last ones first, because then I'm multiplying two things onto everything at the end. It'll make sense when I get there. So my x plus 2 stays, and I FOIL this out. So I have x squared minus 4x minus 3x plus 12. Then I'm going to combine my like terms in there. So I have x plus 2 times x squared minus 7x plus 12. And then I have to FOIL this again, and it's not really FOIL, but you know what I mean. We're distributing these all three, and then we'll do it again on the bottom for all three. If you use the box method, you can be using the box method right now. I'm not going to make you use FOIL just because I use it here. All right, that gives me x to the third minus 7x squared plus 12x plus 2x squared minus 14x plus 24. All right, combining my like terms, I see squareds here, I see x's here, so I get x to the third minus 5x squared minus 2x plus 24. And this is the polynomial that is the simplest polynomial that has those three roots. So that would be my answer. Once I get it all multiplied out, I'm done. Okay, so now I'm going to divide this off. There we go. Okay, next one. I do the same thing, but now because I have I, remember I have x plus 2i and also x minus 2i. I'm going to use x minus 1 because I'm taking opposites, and also x plus 2 for the same reason, taking opposites. All right, so I'm going to do this in a somewhat strange fashion. I'm going to FOIL the ones with the x's with no i's first here. I'm going to FOIL those. And that gives me x squared plus 2x minus 1x minus 2, which is x squared plus 1x minus 2. And then I'm going to separately FOIL these conjugates. If you're ever working with conjugates, you want to multiply them first because they are a pain to deal with if you don't take care of them early. So I do x squared minus 2ix plus 2ix, and then minus 4i squared x. No x. I can't read. It's okay. I squared. So it's I squared. And I told you I was going to run out of space. So hopefully you're using the back of your packet because that's not enough space. What we notice here when we're doing complex conjugates is these two middle terms cancel, leaving me with x squared minus 4i squared. And if you remember correctly, I squared is the same thing as -1, so we can get rid of the I squared and put in a -1 here. And when we do that, we get x squared plus 4 because it's negative times negative makes positive. And then I have my x squared plus x minus 2, which I now have to FOIL out. So it is a lot of work when you get a bunch of terms like this. I'm not going to be mean like this all the time, I promise. I won't use this many. But we're multiplying this all out now. So I do x squared times x squared is x to the 4th plus x to the 3rd minus 2x squared plus 4x squared plus 4x minus 8. So then I take, oh, I didn't have a like term for that one. I take my like terms and put them together. As soon as my computer stops freezing, I have x squared and x squared. I'm going to put those two together. And that gives me x to the 4th plus x to the 3rd plus 2x squared plus 4x minus 8 for my total final answer. All that work just to get this little piece right here. Like I said, I'm not going to be that mean all the time. This is just a very long example with lots of pieces to it. All right. So our last one has two roots, which is much closer to what I will ever do to you when you have a square or an I, a square root or an I. So we have x minus 5 as one factor, and we have x plus the square root of 7 and x minus the square root of 7. And we're going to take care of our conjugates first, just like in our previous example, just because it makes it a lot easier to deal with. So I'm going to bring down my x minus 5. And then here I get x squared minus the square root of 7x plus the square root of 7x. And then minus 7 times 7 is 49, and the square root of 49 is 7. So all you have to remember is when I'm multiplying two of the same square root, the square root drops off. Okay. So next, these two cancel, giving me x squared minus 7. This comes down as x minus 5, and we're ready to do our final multiplication. So we FOIL that out. I've got to write it over here because I ran out of room. I get x squared, x to the 3rd, because it's 1 plus 2 makes 3. So I have x to the 3rd. Let me write that better. I don't like the way that looks. X to the 3rd minus 7x minus 5x squared plus 35. So the only thing left to do is put this in standard form. So I have x to the 3rd minus 5x squared minus 7x plus 35 for my final answer. All right, at this point, I would like you to pause your video and give these two a try. I'll come back in a minute and see how you did. All right, let's see how you did. The answers are now on your screen. Remember, you need to show all work to get full credit for this in class. All right, this concludes our lesson. Thank you for joining me, and I look forward to seeing you in the next video.